So, example 2. Everybody with me? Alright, this is the same as the last question that we did as far as what it's asking for. It is a little bit different, and that the equation is going to be a little bit more difficult to solve. So, whenever you're looking for increasing or decreasing, what you want to know, the way that we prove that, because this is not going to be calculator active, you can't graph it, is looking at whether the derivative is positive or negative. If the derivative is positive, your graph is increasing because you have a positive slope. If the derivative is negative, the graph is decreasing. So, so we will take the derivative of this, and this is a chain rule problem. So we've got the something raised to the 2/3, and then on the inside, we have to take the derivative of this. So for chain rule, we multiply out front by that 2/3, leave the inside exactly the same, subtract 1 from your exponent, so you'll have -1/3 there, and then you are going to multiply by the derivative of the inside, which is just a 2x right there. It will be much better for you if you simplify this before you try to do the next step. So, so if you know, like this is over 1, this right now is over 1. If we move our negative exponents back down to the bottom and combine things, we'll have a 4x there on the top. We will have on the bottom a 3. And then I'm going to make that, that's going to be to the 1/3 on the bottom, but I'm going to go ahead and make that a cube root of x squared minus 9. You can make it to the 1/3 if you'd rather. I think cube roots are a little easier to deal with. There. Everybody okay on the derivative there? So, you know, one good thing about this sort of stuff is like all that, or bad thing, depending on how you feel about it, is that all that derivative stuff that we have been learning, you're going to keep doing in this unit because you got to take the derivative to be able to find increasing and decreasing. So you're going to get more and more practice with that. So if you maybe weren't so great, this will give you more practice on it. If you've already got it mastered, this will help you keep up so you don't forget how to do it. So whenever we get our derivative, we now need to find critical points. Critical points mean the derivative is 0 or undefined. If the derivative is 0, the numerator will equal 0. If the derivative is undefined, the denominator will equal 0. So that numerator is very simple. X just equals 0. There is a critical point. For the denominator, you could divide off that 3. You're going to get cube root of x squared minus 9 is still going to equal 0. You cube both sides, you still get x squared minus 9 equals 0. If you shortcut that because you realize that's going to happen and just start with x squared minus 9 equals 0, that's okay too. And then that'll be x squared will equal 9. And then we will square root both sides. And what do we get there? Okay. What needs to go with that 3? Plus or minus. And that's really important because that's 2 critical points right there. If you don't have the plus and the minus, you're going to be missing some of the answers for this. So, I'm going to show you the way that I prefer to do this. You don't necessarily have to do this for these problems. We want to take our critical points. We want to put them on a number line. And we'll have -3, 0, 3. Now, we did this some when we were doing rational inequalities in pre-cal. What we need to know is whether or not these are positive or negative. So when we were doing that in pre-cal, we made like a chart for this. So we're going to make a similar chart for this to tell if this is positive or negative. Because if we break it up into pieces, it makes it a little bit quicker to look at. So, sometimes you can factor, this is not factored, but if that numerator we can look at whether the numerator is positive or negative. We can also look at the denominator, which is the 3 cube root of x squared minus 9. So what I like to do is I like to look at those separately, and then you can use that for your chart. So I just put the numerator up here, the denominator down here. And if that denominator was like factorable, we could factor it out, but that's not necessary on this. Can you have a negative under a cube root? Yes, a cube root is fine. If that was a square root, it'd be different, right? But this is a cube root. So, so if I'm thinking about plugging in numbers to this, I'm just going to do like a piece at a time. So for this, if I'm plugging in a number right here, like -4, well, -4 times 4 would just give me -16. That'd be a negative right there. If I plug in something between -3 and 0, like -1 into this, I'll still get a negative. But when I start plugging in numbers over here, like between 0 and 3, like 1, I'll get a positive. And anything above 3, I'll also get a positive. Right. The reason I like to do the chart is because it's a lot easier to plug it in like little piece by little piece right there. For this part, is the 3 going to change the sign of what you're talking about at all? Is the cube root going to change the sign of anything you're talking about there? The cube root doesn't change the sign. Like if you take the cube root of a negative, it'll still be negative. If you take the cube root of a positive, it'll still be positive, right? So the 3 and the cube root really don't affect the sign. What you're really wanting to know is whether x squared minus 9 is positive or negative right here. So when you're thinking about that, that can help you do that a little more quickly. So if I have like -4 squared, right, that'll give me 16 minus 9. That's going to be positive right there. If I pick something in here like -1, -1 squared would be positive 1 minus 9. That's going to be a negative right there. Same thing is going to happen if I plug in a positive 1. 1 squared minus 9 is still going to be negative, so I'll get a negative there. And if I plug in a number bigger than 3, like 4, 4 squared minus 9 is going to be positive for that. So whenever you have all of your pieces figured out, then you can look at your answer as a whole for our derivative. And so does anybody remember how we decide what we get here? A negative and a positive would be negative. Yes? Very good. Negative and positive. Both positives also positive. If you have an odd number of negatives in your column there, you're going to get a negative. If you have an even number of negatives, you will get a positive for that. So this line right here is the one we want to look at to answer our question. This is just to help you do it a little more quickly. What you could do instead, so let me give you this option if you do not like the chart, because you do not necessarily have to make the chart. What you can do instead is you can, like pick a number right here, like -4, and you can plug it into the whole equation. 4 times -4 over 3 times the cube root of -4 squared minus 9. And so that gives you -16 over 3 times the cube root of, let's see, 16 minus 9 is going to be 7. And you can't do what's in the bottom without a calculator, but you know it's going to be positive. So negative over positive is negative. You only really care about whether it's negative or positive, not what the actual value is. So if you don't like making the chart, you can do what I've done here for each section, like plug it back into the derivative to see if you get a positive or a negative. I find the chart helpful, particularly on ones that are more complicated, that have more pieces. It makes it a little faster to do. So this question asks us about where the graph is increasing or decreasing. So if we think about what is happening here, when our derivative is negative, what's going to happen to the original graph? decreasing. Derivative is positive, the original graph will be increasing. So we would say f of x is increasing, and there is a little bit of a, as far as the brackets and parentheses go, here, although I did look up, let's finish this question, then I need to tell you about my looking up in my Facebook group the answers to my questions here. So, you are supposed to have brackets for increasing and decreasing. However, -3 and +3 are going to give you a 0 in the denominator. So, can x equal -3 or +3? They are not in the domain, so, of the derivative. So, oh wait, but we care about the original. Actually, I think we just only care about the original, so ignore what I just said. Because while they're not in the domain of the derivative, they are in the domain of the original, because the original does not have a denominator here. So we're okay. We don't need to worry about this. So use brackets unless it's parentheses, -3, 0, and 3 infinity, because you must always have a because, and your reason always has to be calculus. So that means you need to be answering with a derivative here. So you're going to say f prime of x is greater than or equal to 0 on those intervals. You cannot say something like, because the graph is going up for those intervals. You cannot say that, because that doesn't prove anything there. You must say, use the derivative for your evidence here. And then we'll say f of x is decreasing for -infinity to -3 and 0 to 3, because f prime of x is less than or equal to 0 on those intervals. When it's talking about increasing or decreasing, their textbooks do it differently. The general consensus is, with the definition the AP gives for increasing, decreasing, you should use brackets. However, there are textbooks that use parentheses. So the good news about this is, while it depends on how you define it at the beginning, which one is correct. So since it is somewhat ambiguous, AP is either going to avoid asking about it or not count off if you do it differently. So they will ask questions like this. So they're not going to avoid asking about this, but if you were to do that with parentheses instead of brackets, they would not count off. While I'm going to use brackets because the definition that AP uses for increasing, decreasing allows for brackets there. They're not going to count off one way or the other. And I'm not going to count off one way or another. It's not a huge deal. Also, this I did look up on the Facebook page. So we had a question like this the other day, where we had like a quadratic that looked like this, and we said that this is absolute maximum and that this is absolute minimum. And I told you that this one right here I felt like was nothing. So it depends on the definition that you use for relative maximum or minimum. If you use the definition that AP uses, where it's you have to have an open interval where that is the highest value. So open interval means endpoints not included, right? So for example, I could like split this off from here to here, not including those points, and this is the lowest point right here. Then that would be a relative, it is an absolute minimum, but it would also be a relative minimum. However, I could not have relative maximums or minimums at the endpoints using that definition, because if I try to split it off, I can't split it off like over here and over here because it's not defined over here. So, best I can tell, the definition that AP uses, this is not going to be a relative maximum or minimum. It would just be nothing. However, there has been the debate and confusion on my AP Calculus Facebook page has happened because in the pre-calculus course that is going to start next year, or next semester, this year, it's already started for some schools that are teaching in fall semester. In pre-calculus, they are saying that that can be a relative maximum. And why they were not more consistent on their definitions is a great debate among teachers. However, I have seen several people, because one of the reasons the AP Calculus Facebook group is so good is because like Mark Corrali, who is like he's like a test developer and a lead everything in AP. Like, he will personally respond to your questions if you ask a question on there. So, like, I feel like the information on there is very good. If he's the one commenting, it's not just like a random calculus teacher, but it's him, or there's a few others that kind of like calculus rock stars. If they respond, you feel like what they're saying is probably correct. They said that AP is just going to avoid asking about that because there are textbooks that do it differently. So if textbooks define things differently, like whether or not that can be a relative maximum, I'm going to say it cannot because of the open interval definition. I'm going to say it cannot, and I would not include it as a relative maximum. However, AP is just going to avoid asking that question since there is debate about it. So you're not going to see it. They will ask you for the absolute maximum minimums of this. They're not going to ask for relative. So they can ask this question. This is definitely the absolute maximum. This is definitely the absolute minimum. And that's all they're going to ask. They're not going to ask you about this point over here because there is some debate about it. Or if there is debate about it, like if there are textbooks that do things differently, like the parentheses versus the brackets, if they do ask about it, they're going to accept either train of thought on that. So it's not something to get like too caught up in, although the math teachers in the math teacher world, there's a lot of talk of this. It seems like it really shows up on my Facebook group, and like when there's trainings and stuff, people are always asking about it. But so I say all that to say you don't really need to worry about it too much. It would be both absolute and relative. So like by the AP Calculus definition, you're saying like you can make an open interval. So like from this green line to this green line, where this is the lowest point. Not including those points. You can't do that on the endpoints because like if the furthest I can go is at that point. So if I'm not including that point, it can't be the highest on that point. So that's why it would, like, this is absolute, because absolute just says it has to be the highest number in that interval. But it would not be relative for that. The relative, basically a relative in the calculus definition is going to have to be a place you switch from like decreasing to increasing or increasing to decreasing. So while this is higher than some points around it, it does not switch from like increasing back to decreasing there. So it's not going to be a relative maximum. Yes. So like if we had something like this right here, that point right there, that would be a relative maximum. Right, and that would definitely be relative maximum because it's not the highest point on the graph, but it is a place where you switch from increasing to decreasing. We could make an open interval, so like if I look from here to here, that's the highest point on that open interval. So that would definitely be a relative maximum. The end point over here, this new end point, pre-calculus definition says it can be a relative minimum. The calculus definition says it is not. They're just not going to ask you about it, though. So it's not something to get too worried about for that. If this kept on going down here, then this would no longer be my absolute minimum. This would be my absolute minimum. And then that one would have to just be a relative minimum. There. So now I've got a really bad picture here. It's been. Yeah, if you want to make this one relative, curve it back up. Actually, this would still be absolute, but it would be. Okay, we. All right, next problem. Where you could spend a long time looking at things that they're not going to ask us about. So let's not there. Although I think I like thinking about things like that. All right, let's get your calculator real quick. Okay, I'll get you some. While we wait on this to come up anyway.
The chocolate calculator from the book fair.
The chocolate calculator from the book fair is not going to take a drink for you. So.
It smells like chocolate. It smells like solar powers.
Good question. Would that even be allowed? Like, there's a list of allowed calculators.
It's chocolate calculator. It's solar powered.
I don't know about chocolate calculator. I know exactly what you're talking about because I've also had one of those at my house before. I have to like threaten my kids. You have to buy books with words in them. You can get a bookmark or a pencil, but nothing else. Because they will come home with a diary, a poster, a chocolate calculator, you know, the invisible ink. Now, I did let Henry get the invisible ink writer thing because I think those are pretty cool. Plus it, you put them in the freezer. Anybody tried that? One girl told me one time if you put them in the freezer, they'll work again.
I just use the juice.
I don't know what that's about, but
This is a problem.
is it still not working? Okay.
It's not working.
There's a chance that those were just bad batteries.
I'll take those.
Let me give you a pack of brand new batteries. So try this. Because every summer I do take the batteries out of every summer I take the batteries out of the calculators because they sometimes get corroded when they sit there. So those might have been ones that were about dead anyway when I put them over there. So try a fresh pack. Let's keep our fingers crossed that they work because I may only have one other calculator over there. Although Lucian is going to have to pay up on that one, and then we're going to go buy us a new calculator when he pays his debts. Yeah. If the calculator dies without obvious trauma to it, I do not charge you for the calculator because sometimes they just quit working. If it comes in and has been ran over by a car, then Liam, what were you looking at?
It was for economic.
He had to walk into the HS sign like,
It's surprisingly only 10 years. It's only 10, so it's actually pretty good answer.
10 years for
10 years
producing.
You make enough bucks, and then you keep it out.
In order to get off track even more, I will let you guys know that we at North Surrey High School, whenever I was there, had real life Breaking Bad.
Yeah.
Our chemistry teacher was fired for having a meth lab in his home.
Why was this not national news?
Wait, what class is this?
It was before Breaking Bad happened. Maybe
So
this
based
is.
on
I don't. Yeah, not so good for him with students. All right. I did have. Huh?
Yeah, Rose dominated a little bit.
We get ourselves in trouble. All right. Let's go graph this equation. So we are. Oh, we're going to hit the green button. All right. So we are going to do sine x plus x. There is a little kink with these calculators that if you write x next to a trig function without putting the multiplication symbol in between it, it is not going to work. So whenever you type x, you have to do times cosine x. If you don't put that times button there, it will look like it's going to work, but it won't work. I'm pretty sure. Even though maybe some of these have a better, newer operating system than others, and some of them do work, but definitely, Lucian, you're going to need to put that times button there. Yeah. Old Bessie is not going to have the newest operating system there, I'm pretty sure. So, we're going to type this in. And notice right here, this is not our function. What is this? This is the derivative. But what are they asking us about? Where what is increasing? Where f is increasing. So what we're going to do is we're going to go to the graph, and I know that it would give us a much better picture if we looked at this on Desmos, but we can't use Desmos. Maybe AP is going to come around before long and put Desmos on there, but not yet. So now they do give us an interval to look at. I probably should have done that first. The interval they tell us to look at is from 0 to pi. So let's change our window. My window is off where I've done something else, so I'm going to go to the window, and I'm going to do 0 to, I think that's pi over 2 I was at. So 0 to pi. I'm going to hit enter, and I'm going to graph. Green button F2 takes you to the window. So green button F2 is the window. And then you're going to do 0 for your X min. Do pi. You can type in pi and it'll turn it to the decimal there for your X max. Now I just graphed it and I could not see enough of the Y for my lower. So I'm going to make this maybe like -3 or something here. Uh-oh. I used the minus key. Yeah, for my Y min. 2.063 was good enough for my Y max. Or you just do 2. It'll be fine. Alright, so make sure you have hit enter on everything that you've put in. And then to go back to the graph, you hit green button F3. Let's see if we can see what's happening here. Okay, we can see good enough. Like I'm missing this last little piece right here, but I'm pretty sure it's not going to shoot back up to positive in that little tiny bit of time. So for this, they're asking us where f is increasing. Which one of those answer choices is going to be correct? Not A. It seems like it should be A. It's not A. What are they asking us about? Increasing for which function?
The original.
The original. Are we looking at the original? No. We are not looking at the original. We are looking at the derivative. So whenever we're talking about the derivative, if I know that f prime is positive, that tells me that f is increasing, right? If I know f prime is negative, that tells me f is decreasing. So we are not looking at whether or not this function is increasing or decreasing. They will almost never ask you a question about the function you're looking at, right? They're asking you to use that to answer either the derivative of that or the function above it. So what do I need to be looking at on this graph to tell where f is increasing? X-intercepts. So I'm looking above or below the x-axis, right? And since it's increasing, I'm looking for where this is positive. So it's positive above the x-axis, right here. Which, if you're in a hurry, if you're about out of time, which answer choice would you pick? B. Because that, although we haven't found that exact intersection, I'm pretty sure that that's going to be it. Now, if I've got plenty of time, what I would do is I would find that intersection and make sure it's the same number, because if it's a different number, then you might have something typed in wrong. So intersection or zeros on this calculator. So to find a zero on this calculator, and you probably haven't even hardly ever used the yellow calculators to find zeros, so this will be all brand new. We've done it maybe before. If you hit F5, that gives you all of your options of things you can find from the graph. We want to find the x-intercepts, which are also called zeros. So that's number 2. We're going to go down here to number 2 for that. So everybody try to follow along. And then it's going to give you instructions on what you're supposed to do right here. So it says lower bound. On the yellow calculators, it says left bound instead of lower bound. So you're thinking lower on the x-axis. So left side of where, so we're trying to find this point right here. We need the little bullseye to be on the left side of that, which it is right there. So I'm just going to hit enter. And now, and when you do that, you see like this little arrow pop up. That's sort of sectioning this off, like we're looking from here over. Now we need upper bound, so we need to go to the right side of that. So if you hit your right arrow here, just you got to get to the right side of that intersection. It can be confusing because we were above it, and upper and lower makes you think above and below, but it is not. It is left and right. You're thinking above and below on the x-axis. So we're going to hit enter, and then it will give you the 0 there, which is 2.029. So that lets us know that this is in fact the correct answer right here. Now, if I was about out of time, I wouldn't even bother doing that step right there, because you can tell it's not 1.077. You can tell by the tick marks where you're at there. Okay, does this make sense on what you're doing? I'm gonna have to ban these Gatorade bottles. This is gonna be like elementary school. Like anything that became popular was eventually going to get banned. Fidget spinners. One point it was all those little silly bands. That might have been before you guys. They were like those rubber bands shaped like different animals. Silly bands had to get banned. Kids were like cutting off their circulation with silly bands.
I remember people would like put like a bunch of those on.
Yeah. Yeah.
I'm gonna get back to those actually.
Yeah, silly bands had to get banned.
The reason why too is because I would be like tribute
Yeah. You're manipulating people for their silly bands. Yeah.
and like the Pokemon.
Yeah. Yeah, pretty much anything popular in elementary school is going to get to the point where it's just going to get itself banned.
Stole my Mega Charizard EX.
I had like 300 cards. I gave them all to Timothy Bridges.
What Timothy's doing today?
I don't know.
Okay.
It's possible.
All right. You guys can look him up on the offender search later. We're gonna do this. If you if you don't know about that, the NC offender search is a good place to go whenever you're wondering if somebody's in jail. So they gotta be 18 though. Yeah, if they're not 18, you won't know yet. Once they hit 18 though, if you want to know if they're in jail, you can, or have been in jail or been charged with convicted of anything, you can go check it out.
What a guy.
I've done that with several people that I went to high school with, because I was wondering, I wonder if they ever went to jail. Some of them did. Some of them did. Fairly well. I mean, I'm looking for people who I think went to jail, so. Yeah, probably 50-50.
Did any surprise you?
I haven't looked up everybody. There's just been a couple do you think he went to jail? My husband, no. I don't know. Let me go check.
Who's in jail?
Let's say
Why'd you say it?
out of my husband and his two best friends in in sixth grade. His two best friends. He's the only one that hasn't been to jail. But he is also the only one that graduated middle school, so. Yeah. So he was not making the best friend choices at that time, but thankfully he decided not to continue following around with that crowd. All right. Okay. This one's not calculator active. So let's look at this one. We're looking for intervals where we are increasing. Now, this one does say open intervals. It's specifically saying open intervals, so they are using parentheses here. They could have just asked for intervals and used brackets. AP just avoids the issue, right? By saying open intervals here, you don't even have to think about whether or not to use brackets. They use parentheses on all of them. So this one's not calculator active, so we're going to have to take a derivative. So f prime of x, what have we got to use for this one? Multiplying one. So we are going to do x plus x squared times the derivative of e to the negative 2x. Negative 2 e to the negative 2x, because the derivative of e to the negative 2x is e to the negative 2x. But then you have to use the chain rule and multiply by the derivative of the negative 2x, which is where that negative 2 comes from. And then we will have e to the negative 2x times the derivative of x plus x squared, which is going to be 1 plus 2x. So it is in your best interest here to factor out that e to the negative 2x. It will make it easier to deal with if you do that. So that would leave this negative 2 that would get distributed to both of those right there. So we'd have negative 2x. Oh, wait, let me write out here front first my e to the negative 2x. Then I will have negative 2x minus 2x squared. And then I pulled out the e to the negative 2x here. So I'm going to have my plus 1 plus 2x. And so for this, that negative 2x and the positive 2x cancel each other out. And I'm going to move my e to the negative 2x down to the bottom so that it has a positive exponent, e to the 2x. And at the top, I'm going to write this way, 1 minus 2x squared. Just because I don't like that negative being first, but you can write it the other way is fine. Negative 2x squared plus 1 is fine. So once we have our derivative, what do we have to do? We need to find the zeros and the places where our derivative is undefined, right? So we're going to set the numerator equal to 0 and the denominator equal to 0 to get those critical points. So we've got 1 minus 2x squared is going to equal 0. So I'm going to add that 2x squared to move it over here. 1 equals 2x squared. I'm going to divide by 2. So I got 1/2 equals x squared. Then what do I have to do? Square root. So I will get plus or minus the square root of 1/2. If it was free response, I would definitely leave it like that. But do you see a square root of 1/2 anywhere over here? No. But what do you see that looks kind of like square root of 1/2? Square root of 2 over 2. So let's simplify this so that we can see if it matches. Square root of 1 is 1. Square root of 2 has to stay underneath the square root. And then what do I do to rationalize that denominator? Multiply by square root of 2 over 2, which will give us plus or minus square root of 2 over 2. All right, so that is square root of 2 over 2. So that should be good because you're seeing that show up in your answer choices somewhere. I'm thinking maybe A is not going to be it because that doesn't show up there. Then if I look at the denominator, e to the 2x, now you may already know where this is going because we talked about this the other day. E to something is always going to be positive no matter what. Even if you plug in a negative, like e to the negative 2 is 1 over e squared, which is still positive, right? It's a small positive number, but it's still positive. So this is not going to give you anything. If you try like taking natural log of both sides, you can't do natural log of 0. Natural log always has to be of a positive number. So you get nothing from here. That value is always positive. So if we make ourselves a number line here, our critical numbers on here are negative square root of 2 over 2 and positive square root of 2 over 2. And you could make the chart if you want. You got 1 minus 2x squared, and you got e to the 2x, and then we got the answer, the f prime of x. So if we do that, now I said you could make the chart if you want. The reason the chart's not totally necessary is because what's the sign of e to the 2x? No matter what we plug in. It's positive. So this is positive all the way across because e to a power is always positive. So since that is always positive, all we really care about is what that top line is going to be. So if I plug in a number less than negative 2 square root of 2 over 2. Now I don't really know what negative square root of 2 over 2 is. But I know negative 5 is smaller than that. So let's do negative 5. 1 minus 2 times negative 5 squared. Negative 5 squared is positive 25. 2 times 5 is 50. 1 minus 50, we're going to get a negative right there. If I plug in 0, which falls in between these two, that would be 1 minus 0, which would give me, oh, I don't need to put the number there, and I was about to put 0, which is incorrect. 1 minus 0 is positive, right? We'll get 1 there, which is positive. And if I plug in a number bigger than square root of 2 over 2. Once again, I don't know the exact decimal, but just pick something, you know, is pretty big. 5 again. 5 squared is 25. 2 times 5 is 50. 1 minus 50 is negative right there. It does not always flip back and forth, negative, positive, like that, but it does a lot of times. So for our derivative here, we got negative, positive, negative. What did they ask us for? Increasing or decreasing here? Increasing. So what would our answer be for this one? D. Okay, questions? All right. All right. Here is the type of problem they love to give. All right. And it always gets somebody. It is a very simple problem, but it always gets somebody. It asks for what values of x is f decreasing. So for this? Anybody know? What values of x would f be decreasing? -1 to 4 is strictly incorrect. What is this the graph of? This is the graph of the derivative. And they almost never, like that worksheet I gave you guys the other day, yesterday, where you were telling me where things were increasing, decreasing, positive, negative, that stuff, they're not going to ask you that because that's not calculus. That is pre-calculus stuff. They're not going to ask you that from the graph they've given you. So they have given you f prime of x. So this is the derivative, and we know f prime of x. If I want to know if f of x is increasing or decreasing, then I have to look not at whether f prime is increasing or decreasing, but whether it is positive or negative, right? So on this graph, I'm not looking for where this graph is decreasing. I'm looking for where this graph is negative, and negative means below the x-axis, so we're looking at right here and right here, okay? Remember, for this, you're always given the domain where this happens, not the y values, but the domain where this happens. So domain, we're looking at, you know, these don't have arrows on the end, but they should here. So this goes on forever and this goes on forever. So we're negative up until this point. So what would I say for the interval there? Negative infinity, not to 3, but -3. And where else? 1 through 5. So we would say f is decreasing for these intervals because f prime of x is less than or equal to 0 for those intervals. They like to ask these. They like to ask them on multiple choice, and guess what would definitely be an answer choice? -1 to 4. Or it might be even meaner where like those are actually exactly at -1 and 4, and then you're really going to think that that's the answer, but it's should pretty much never be asking you about the graph you're looking at whenever you're looking at these. So, questions on that? Does that make sense? All right. Okay. Let's look at this one. The function f of x equals x squared minus a squared, where a is a positive integer. Give the values of x in terms of a for which f is increasing. Justify your answer. They give these sometimes. It's always a pain whenever they start throwing those like letters in there, the extra letters, right? Where we're not going to get number answers for this, but they like to do it. So, if we have f of x equals x squared minus a squared, and we want to know where, and a is a positive integer, we got to give the values of x, although I don't know if it matters that a is positive, but that's okay. Give the terms of x in terms of a in which the f is increasing. So if we're looking for increasing, we can't look at this function. We've got to look at its derivative, right? So we're going to take the derivative of this. What is the derivative of x squared minus a squared?
2x minus 2a.
Just 2x. Because what is a? A is just a number. So we're not like taking this, it's not a separate variable because it tells us that it is a number. So if it was a second variable, which this would be like three-dimensional calculus, this is not you don't get 2 till Calc 3, you are correct. We would need a dA dx with it if A was a variable. But that would be multivariable calculus, which you don't do until you get to Calc 3. So Calc 3 is kind of cool because it's like everything we're doing here is like on the coordinate plane. It's like 2-dimensional. But Calc 3, you have like an X, Y, and Z coordinate, and it's like all 3D stuff, and it's pretty cool. But we're not going to go there because we got to learn some Calc 1 first. So A is just a number. It told us A is a number, so when we take the derivative of it, that derivative is 0. So this is a very simple one as far as figuring out where this critical points are. Your critical point is just 0. So you would make yourself a number line, and 0 is going to be on it, and it's going to be very, very straightforward, because if I plug in a negative number, something below 0, what am I going to get for my derivative? Negative. And if I plug in something above 0, what do I get for my derivative? Positive. I think I meant for this question to be more complicated than this. I think I did, because it says in terms of A, but you're not going to have any in terms of A for this. Yeah, I think I meant for it to be more complicated than it is, because that A basically goes away. You're not going to have an A in your answer. So I think I might go back. I think I know what I meant for this to be, because this is too simple. This is too simple the way it is written. Let's finish it. Let's finish it. It's asking where it's increasing. We would just say F is increasing for 0 to infinity, because F prime of x is greater than or equal to 0 for this interval. This is too simple. I think I know what I meant for this to be. I think. But you're not going to run into it on your homework, so I might do something like this for a warm-up or something sometime, because I might need to run through it first instead of coming up with this as I go. I think I meant for that to be F prime. If it's F prime, it changes it a lot. If that's already the derivative, I think that's what I meant for it to be. And it'll be x plus a and x minus a. I'm pretty sure that's what I meant for it to be. But we're not going to do that right now, because I might mess it up. All right, so the assignment that you're going to have that goes with this, this is different than what I had in Canvas, so let me look and see if this is what I want. It's not that many columns. Let's see. I am not going to have you, we have already done a lot of the stuff from the graph where I gave you guys that worksheet. So I am not going to give you 1 through 8, because that's just asking you to do it from the graph. It's like pre-calculus stuff, so I'm not going to ask you to do that. Okay, I think 9 through 20 is fine. That's fine. Yeah. 9 through 20. All right, and you have some time to work all that. Oh, God.